Good morning. This is an introduction to solving one-step equations, but before we begin, I wanted to go over the things that we should know before going into solving equations. Number one is that there are four operations in math. There's addition, adding, subtraction, subtracting, multiplication, and division. So those are the four operations in math. The other thing we should know is that each operation has an opposite operation. For example, the opposite of hot is cold, and the opposite of cold is hot. It goes both ways. The opposite of black is white, the opposite of white is black. It goes both directions. Well, mathematically, we know that the operation that's opposite of addition is subtraction, and the opposite of subtraction is addition. Similarly, the opposite of multiplication is division, and the opposite of division is multiplication. So this is like a basic rule we really have to remember from day one because we're going to be using it practically every day in Algebra 1. Another thing to remember is that when we're solving one-step equations, or any equations for that matter, we can make any change at all to an equation, as long as we make the change on both sides of the equation. So I'm going to go over this example really quick to show what I mean by that last rule. When we look at this equation here, on the left side we have 5 plus 5. And this equation says that 5 plus 5 is equal to 10. Well, what if I wanted to do an operation on the left side of my equal sign? What if I wanted to add a 1? Are these two sides of the equal sign still equal? Well, no, because 5 plus 1 is 11, and that's not equal to 10, unless I do that same change on the right-hand side. So here we've got plenty of examples of solving one-step equations, and you may notice that each column has a different type of operation. For example, in our first column, all of these have to do with addition. In the second column, each example has subtraction. In the third column, we see multiplication, and that occurs when two numbers or variables are stuck together. And then finally, we have division, and division is usually represented by a fraction in Algebra 1, so that's how we're going to see each of these. So to start out, I'm going to start off with the first column and move onwards. Now, the one thing we have to remember is in order to get something by itself, in order to get rid of something, we have to perform the opposite operation of whatever's there. So looking at example 1, we notice that m is on the left-hand side, and there's a 2 being added to it. Well, to solve for something, we need to get it by itself. So the opposite of addition in this case is subtraction. So I'm going to do minus 2 on the left. But the equality doesn't hold anymore because I only made a change on the left side. So to correct that, I need to do the same change on the right. Well, in this case, we know that 2 take away 2 is 0, so that cancels. All that's left is to bring down our variable. On the right side, 8 take away 2 is 6, so that's what's going to move down. You'll notice that the m is by itself, so we've officially solved this equation, and that only required one step. Let's do the same trick with number 2. I notice that my variable's on the left, and there's addition present, so I need to get rid of that normal number, that constant. To get rid of the 10, I do the opposite of plus, which is minus, but I have to do it on both sides. 10 minus 10 cancels. We bring down our variable, and then 12 minus 10 is 2. The variable's by itself, so we're done. Now you might notice that number 3 is a little bit different. The variable and the constant switched positions, but that's okay because we always want to get rid of the constant, that normal number. Now looking at that 3, I see that it's positive because there's no sign in front of it. So I want to get rid of the 3 by doing the opposite. I still have to make the change to both sides. Now I'm going to bring down my variable, and I don't have to bring down the plus sign because we already know it's positive when there's no negative present in the front. On the right, 10 minus 3 is 7, and because our variable is by itself, we know that we're done. Now let's look at the second column. I notice that I have subtraction here, and the opposite of subtraction is addition. So I'm going to add 7 to both sides. That way, it disappears from the left, it cancels. I bring down my variable, and on the right side, 3 plus 7 is 10. X is now by itself, so I'm done solving. This same process will help us with 2 and 3. I see x minus 4 is present, so to get rid of the minus 4, I'll do the opposite, which is plus 4. The 4's cancel. I bring down the variable, and when I add on the right side, 2 plus 4 is 6. Next, I'm looking at number 3, and again the positions are flipped, but all we care about is the sign that belongs to the constant. Since that 4 is negative, in order to get rid of it, I have to do the opposite. The opposite of negative or subtraction is addition. So by adding 4 to both sides, the constants cancel. My variable is left alone on the left, and on the right, 4 plus 4 turns into 8. Now let's look at column 3. I notice that the 3 and the x are stuck together. Now in Algebra 1, we learned that when two things are stuck together, they're actually being multiplied. It used to be represented as x, but now we use dots or even parentheses at times. In this case, we have to remember to get rid of something, we do the opposite, and the opposite of multiplication is division. Now, you have to be careful. You only want to divide by the number you're trying to get rid of. Because we want x by itself, we need to divide by 3 because that's the item that's stuck in the first place. When we do this, 3 divided by 3 reduces to 1x. You can put the 1 if you'd like, but it's kind of invisible. So we have 1x remaining. And on the right, when you do 30 divided by 3, you get 10. Doing that same step with number 2, we notice that the 10 and the x are stuck together. We need to undo it by doing the opposite operation. We want to divide by the number that's stuck to our variable, and by doing so, the 10's reduced to an invisible 1, x is by itself, and 70 divided by 10 is 7. Doing that one more time with problem number 3, we notice that the 4 and the x are stuck together. To undo that, we divide, and we divide by the number that's stuck to the variable. 4 divided by 4 reduces to 1, which is just 1x remaining, and then 12 divided by 4 gives us 3. Looking at the last column, we see fractions, and fractions imply division is happening. So remembering what the opposite of division is, we know we need to multiply. And you always want to multiply by the number that's in your denominator. It's on the bottom of the fraction. So on the left side, I'm going to multiply by 2. But I also have to do that on the right. When I multiply, the 2 and the x become stuck together, and that 2 remains on the bottom. 4 times 2 on the right side give us 8. Now you might notice x is not by itself yet, but that's because we haven't simplified our fraction yet. When you take 2 divided by 2, it reduces to 1, and you're left with 1x equals 8. Following that same process with number 2, I see a fraction, which means division is happening. I need the opposite of division to get rid of my fraction, which is multiplication. I need to multiply by 10 because that's the number that was stuck on the bottom of my fraction. When I multiply the left-hand side, I get 10x divided by 10. When I multiply the right side, 6 times 10 gives me 60. Now, when I look at the left and I see 10 divided by 10, I know that reduces to 1x, and I'm left with x equals 60. Finally, for example 3, I see a fraction, which implies division is happening. I need to multiply both sides because that's the opposite of division, and I multiply by the number in the denominator. When I perform the multiplication on the left, I get 3x divided by 3, and on the right, 3 times 3 gives me 9. I'm not done until I fully simplify both sides, and on the left, I know that 3 divided by 3 reduces to 1x. When I bring down the right-hand side, I get my answer, x equals 9. So these are the 4 types of one-step equations you can see in Algebra 1. Later on, we'll learn about 2-step equations, 3-step equations, and multi-step equations, but it's all the same steps that we've seen in today's video.